Hello there, this is an Algebra 2 video. It's Chapter 8, Section 2, Adding and Subtracting Rational Expressions. And if you're going to be adding and subtracting a fractional expression, just like when you add or subtract fractions, you need to have a common denominator. And so in order to find a common denominator, you have to be comfortable with finding least common multiples. So in example 1, that's the first thing we're going to do is find the LCM, the least common multiple of each set of polynomials. So to do that, we'll take the first term, the 6xy, and you want to factor it down to prime factors. So for 6xy, that'll be 2 times 3 times x times y. And then for the 15x squared, you're going to have 3 times 5 times x times x. And then we're going to have the 9x to the fourth, 9xy to the fourth, sorry. And that's going to be 3 times x times y times y times y times y. And so our job is to find the least common multiple. And when you try to find the least common multiple, it is very important that you recognize that the least common multiple is going to contain every factor, but the greatest number of times it appears as a factor. So for example, every factor means that there's a 2 in this term, there's not a 2 in this term, not a 2 in this term, doesn't matter. Every factor present needs to be present in the least common multiple. So we have a 2. Then you have a 3 because there's a 3 here. But we also have to have the greatest number of times that it appears. So it only appears once here, but here it appears twice. So we need 3 squared. And then for the x, same thing. It appears once here, but twice here. So we need an x squared. And then we need the y. It appears once here, not at all here, but 4 times here. So at the end of the day, we have 2 times 3 squared, which is going to be 2 times 9, which is 18. X squared y to the fourth. That is going to be our least common multiple for part A. All right. I'm so sorry. I forgot the 5. There's a 5 missing here. There's a 2, there's a 3. We got those in there. Oh, we forgot the 5. What's 18 times 5? Let's correct that real quick. 18 times 5 is going to give me a whopping 90. So actually, this should say 90x squared y to the fourth. That was a close one. All right, so now we're going to go on to part B and do the same thing. Only this time, our terms are a lot bigger because there you only had 6xy, you had 3 different terms. Here, this is all one term, and this is all one term. So before we can even start writing out the least common multiple, we have to factor these little guys. Okay, so for the first one, here, they all have a y squared in common, so the y squared is going to come out, and I'm going to be left with y squared plus 8y plus 15. And then I'm going to then furthermore use my factoring techniques. I'll have a y and a y there. For 15, we can do 5 times 3. 3y plus 5y is going to give me 8y. So it turns out that this very first term here, complete factorization, is going to be y squared times y plus 5 times y plus 3. Those are all of the factors of the first term there. So then for this little guy, we're also going to do y, y. And then for 40, we can do 8 times 5. And one of them has to be negative, so I'm going to say that negative 8y plus 5y is going to give me the negative 3y that I need. So then this factorization is y minus 8 and y plus 5. So now that we've factored everything, we need to write the least common multiple. And again, it's going to be every factor present and the greatest number of times that it's present. So the y squared is definitely going to be part of it. And then we have y plus 5 in both, but they both only have y plus 5 to the 1 power. So we have y plus 5 to the 1 power. And then we have a y plus 3. And we also have to have the y minus 8. So at the end of the day, this whole shebang bang ends up being our least common multiple. Y squared times y plus 5 times y plus 3 times y minus 8. And they don't necessarily have to be in that order, but you have to have all of those factors present in your least common multiple. So now you will try this do-it-yourself question, and then we'll move on to actually applying some of this adding stuff and subtracting stuff. All right, we're going to start with some smaller fractions and then move on to some of the bigger ones. So here we go. We need to find our least common multiple so we can have a least common denominator. And so for this little guy, since we have a 2x cubed, that's going to be 2 times x times x times x. For the 8xy squared, you're going to get 2 times 2 times 2, which is 8, times x times y times y. So for our least common multiple, we're going to have the 2, but we have to write 2 to the 3rd power because it has to be the greatest number of times that it's present. So we have 3 of them here. We need the x, which is also only one x here, but we have 3 of them here. So we have x cubed. And then we need the y's for y squared. So at the end of the day, our least common multiple is 8x cubed y squared. And so that's going to end up being our common denominator. We're going to want to have 8x cubed y squared on the bottom of our fraction. However, the question becomes, how do I get that from both of these denominators? Because this has a 2x cubed, so what is it missing? So we need to multiply the top and the bottom of this fraction by whatever factors it's missing. We need to multiply it by 4. Because 4 times 2 will give us the 8. It already has an x cubed, so we need to multiply it by y squared. That way you get 4 times 2 is 8, 8x cubed, and then the y squared. So on the top we're going to get 4 times 3, which is 12, and then y times y squared, y cubed. On the second fraction, we already have the 8, we already have the y squared, we need an x cubed, and we already have 1x, so we multiply by x squared and x squared to get the x cubed. Alright, so we're going to get on the top 5x squared z. And since they don't have anything in common on the top, we can't really simplify it any further than that. Our final answer is 12y cubed plus 5x squared z, all divided by 8x cubed y squared. And that's how we implement the LCM into adding our fractions. So now you will try this do-it-yourself question, and then we will do more, but they get more complicated as we go. All right, so in this case, you want to factor. Factoring is going to be your friend. So we can take out the 6 and get x minus 3 because 6 times 3 is 18, last I checked. And then on this side, we're going to use our factoring techniques. So I'm going to say 2x and 2x to get 4x squared. And then for the 6, I'm going to do, a 3 and a 2 and see what happens. I need them to both be negative if I want this to be a negative 14 here. But it turns out that I've got negative 4x and a negative 6x, and that's only going to give me negative 10x's. So that's not going to be the right way to go. So I try something else. Still using the 2x and the 2x, but now I'm going to use maybe 6 and 1. And again, we want them to both be negative. And so this time I'm going to get negative 6 times 2 is negative 12x. and negative 1 times 2 is negative 2x, and this time negative 12x and negative 2x is negative 14x. So this is the right combination to have. So I come over here and I'm going to get 2x minus 6 and 2x minus 1, but I also noticed that both 2 and 6 have a 2 in common, so now the 2 needs to come out. So that'll be x minus 3 and 2x minus 1. So now that both fractions are completely factored, it's my job to then find the least common multiple. So in this case, for our least common multiple, we are going to need, here we have a 2, and here we have a 6. So we're going to need the 6. We have an x minus 3. And we also have a 2x minus 1. So, again, in this case, it would be 2 times 3 for the 6. But they have the same 2 and the 3, so it will be a 6 there. I hope that didn't confuse anybody there. But now we have our least common multiple as 6 times x minus 3 times 2x minus 1. And so now it's a matter of multiplying the original fractions by whatever they're missing. So I look at the original fraction here, the 6, it has a 6 and it has an x minus 3. So what it's missing is the 2x minus 1. So I need to multiply the top by 2x minus 1 and also the bottom by 2x minus 1. Okay? So basically this 6 times x minus 3 replaced the 6x minus 18. I don't need this 2 times 3 there anymore. Okay, so then over again here, this all got replaced by this factor here. So in this case, we have an x minus 3, we have a 2x minus 1. The only thing that's missing in the second fraction is the 3, so that it can become a 6. So we're going to times this by 3 and times this by 3. Now both fractions will have the same denominator, which is going to be 6 times 2x minus 1 times x minus 3. And on the top, we're going to have 5 times 2x minus 1. And then there's a minus symbol right there. Minus 3 times x minus 1. And our last step is going to involve us trying to simplify the top. 5 times 2 is 10x. 5 times negative 1 is negative 5. Negative 3 times x is negative 3x, and negative 3 times negative 1 is positive 3. So we're going to get 10x minus 3x, which is going to be 7x. And then negative 5 plus 3 is going to be negative 2. So at the end of the day, the answer is 7x minus 2 over 6 times 2x minus 1 times x minus 3. And again, they don't have to be in that order on the bottom, but there's our final answer. 7x minus 2 over 6 times x minus 3 times 2x minus 1. So now you will try this little guy, and then we're going to go to our next example. And our next example, we're going to do it in 2 different ways, and then we're going to allow you to choose which method you find easier for you. So this is the first attempt, and we're going to be using different LCDs with this guy. So we're going to do the same problem twice, in example 4 and example 5. But we are dealing with complex fraction. A complex fraction just means you've got a fraction within a fraction. So what we can see in this example, or this problem, is that the least common denominator for the numerator, because this is the top of the fraction. When I say numerator, I'm talking about this big thing here. The least common denominator is going to be x, because the bottom of this one is x, and it doesn't have a bottom, so we assume it's 1 over 1, so the least common denominator is going to be x. In the bottom, the denominator here, the least common denominator is going to be y. So one thing that you can do is to deal with them separately, and therefore take 1 plus 1 over x and times that little guy. Well, let me see if I can. Okay, so I want to go Yes, that's what I wanted to do. I'm sorry for erasing that. I want this little guy. Okay, so one thing you can do is multiply the top and the bottom over here and the top and the bottom over here separately. So you could get x over x, which is the same thing as 1, y over y, which is the same thing as 1, and then you would have x over x plus 1 over x, and then over here you'd have y over y minus x over y. And you can see what I mean by the common denominator here would be x, common denominator here would be y. And then you could go and do, since they have the same denominator, you can combine the tops to get x plus 1 over x. So now you've taken the two separate fractions and made it one fraction. On the bottom, you do the same thing. You can go y minus x over y. And then, of course, we learned in our previous lesson that you could flip the second fraction over and multiply. So that would be x plus 1 over x. And instead of dividing, you'd be timesing by y over y minus x. And then you could multiply across, and you would get x times y is xy. And then 1 times y is just y. So you get xy plus y on the top. And then x times y is xy. And x times negative x is negative x squared. And at the end of that long process, you would have xy plus y divided by xy minus x squared. Alrighty? So now you can try these examples. But I'm going to go ahead and now do the same exact problem, only a little bit differently. And hopefully, I feel like this method is a lot easier. But again, you can do it whichever method is easier for you. So we'll start off with the 1 plus 1 over x again, 1 minus x over y. And this time what I'm going to do is instead of multiplying or trying to combine each fraction individually by multiplying by x on the top and by y on the bottom, is I'm going to multiply top and bottom by the combination of the two denominators, which is x times y. So what if I took the denominator here x and the denominator here y and multiplied both fractions by xy instead of just individually by x or by y? Well, what's going to happen here is xy times 1 is just going to be xy. But xy times 1 over x, the x's are going to cancel, and I'm just going to get 1 times y, or plus y. On the bottom, I'm going to get 1 times xy is xy. And then when I take xy times x over y, the y's are going to cancel, and I'm only going to have x times x, which is negative x squared, and I get the same exact answer that I got earlier, xy plus y over xy minus x squared. Xy plus y over xy minus x squared. You get the same exact answer, but you just get it a lot faster. But sometimes that might seem confusing for people, so I don't want you to feel like you have to do it this way, but it is a lot easier and if you can follow what's going on. So again, you are welcome to do in the future, you have to do these do-it-yourself questions. There's actually 4 of them. There's A, B, and then C and D. And you can, and after you do this example, you can use whichever method is better for you when you do the homework. But for this do-it-yourself question, I want you to try doing it the way that I did it in the example. All right, but once you have completed this do-it-yourself question, then you will have completed your notes for this lesson, and I will see you in class, and thanks for watching.